Okay, so scientific notation. I'm going to show you how to write between scientific notation and standard form of a number, back and forth. So here we go. Let's go to the first example. Here we have a number that is already in scientific notation. It's 5.35 times 10 to the fourth. This is what is known as scientific notation. Some number times a factor or a power of 10, or 10 to some power. That's how we could say it. Product of 10 to some power. This number over here on the left of the factor of 10 has to be between 1 and 10. So sometimes you'll see whole numbers, uh, but most of the time you'll see some form of decimal number that's between 1 and 10. So you'll never see something that's 11, 12, 20, 1000. If you do, it's not scientific notation. Okay, so how we read this, we look at this part of the scientific notation and specifically the exponent. The exponent lets us know where to move this decimal point. So if this is a positive exponent, it means we're going to move this decimal point to the right, and in this case 4 times. So say we have this 5.34, so we got to move this decimal point to the right 1, 2, 3, 4 times, and we're going to fill each of these little loops that have no number there with a 0. So in essence this becomes 53400, or 53,400. Some may ask, why did we move the decimal point? And some won't. But just in case, this 10 to the fourth, if you recall, means 10 times 10 times 10 times 10, or 10,000. So in essence, what we're doing is taking this 10,000 and multiplying it times this number 5.34. 5.34. So if you multiply this all the way out and move the decimal, you will get this number, 53,400. But instead of doing all this work here, we just know if it's a positive exponent, it moves the decimal to the right that number of spaces. Again, we have another number that's already in scientific notation because this is between 1 and 10, and we have it being multiplied times a base 10 power, a power of 10, or 10 raised to a power. So once again, we take a look at this section of the scientific notation, specifically the exponent. It is a -3. So since the 3 is negative, we're moving to the left 3 times. So go 1, 2, 3, and again, any empty spaces we will fill in with zeros, and our decimal point is in that new position. So 0.00327 is that number in standard form. It looks like a decimal. You can also put a 0 out here if you want. That's 0.00327, so it could look like that too. Okay, now in this example we have a number in standard form, 3,725,000. We want to write this in scientific notation form. So we know the basics. We need to have something times 10 to some power. So let's go ahead and figure out what goes where. First, we need to identify where the decimal is. The decimal in 3 million will be way over here on the right hand side. And now we need to decide how many times do we move this decimal so that this number will be between 1 and 10. So that means I want to move that decimal all the way to this spot right here. Okay, right there. So we count how many spaces. 1, 2, 3, 4, 5, 6. So the exponent is going to be 6. And why is it a positive 6? Well, the standard form number was a big number, so therefore my exponent is going to be positive. the new number that is created from moving the decimal from the right all the way over here between the 3 and the 7 is 3.725. Again, a number that's between 1 and 10. So this is the number in scientific notation. Okay, once again, in this example, we have a number that is in standard form, a decimal number, and we want to write it in scientific notation. Again, we need to have this power of 10, but so now we got to fill in these two spots. So again, find the decimal, move it. So we're moving 1, 2, 3, 4, 4 right there between the 3 and the 1, because if I go over here between the 1 and 6, that becomes 31. Right here, if I stop right here, this is a 3 wholes 0.16, so that's between 1 and 10. So we go 1, 2, 3, 4, so 4 spots. Now remember, in example 3, when we moved 6 spaces from a big number, it was positive. Well, decimal numbers are small numbers, so our exponent is going to be a negative. Or if you notice, we moved in the opposite direction. And our new answer, oops, I should have put that in a different color right here, is 3.16 to the negative 4th power.